19, and we set the 32 position to 1. 16 is less than 19, so we set the 16 bit position to 1, and subtract, and we get 3. And then 8 is bigger than 3, so we put a 0 in the 8 bit position. And we still have 3. 4 is bigger than 3, so we put another 0 in the 4 bit position. 2 is less than or equal to 3, so we put a 1 in the 2 position. And we subtract and get 1. We're left with 1. 1 is less than or equal to 1, so we put a 1 in the 1 position. And this is the binary format of 51. Excuse me. I'm going to go fast through the first couple examples, and we'll open it up after that. So negative 12, this is the binary representation for 12. You take the 2's complement of 12, and you get this number, which is negative 13. You add 1 to it, and you get negative 12. So 1, 1, 0, 1, 0, 0. So the next number, we have a binary representation. We don't know what it is, so we're going to try to figure that out. The sign position is 0, so we know it's positive. The 32 position is 1, so we keep 32 in our little accumulator. The 16 position is 0, so we still keep 32 in the accumulator. The 8 position is a 1, so we add 8 to 32 and get 40. The 4 position is a 0, so we keep 40 in the accumulator. And the 1 position is a 1. I mean, the 2 position is a 1, so we add 2 to 40, we get 42 in the accumulator. And the 1 position is a 0, so we keep the value in the accumulator of 42. And that's the answer to that problem. The next one, the first bit is a 1, so we know that it's a negative number. So this is negative x. If we take the complement, we get x minus 1. We add that 1 to that value to get the 2's complement, and that will be x. And that's 43, which is basically the last 42 number plus 1. So the answer, x is 43. We want negative x, so the answer is negative 43. And we'll fill in the table. Okay, next one is a shift. We're shifting things of that, of negative 4. So we'll take 4, because I don't do negative numbers off the top of my head. We'll complement it, we'll add 1 to it, and this is negative 4. We're going to shift it 5 positions from the left. That means the digits in red are going to fall off, and we're going to get new digits in red, which will be zeros. When you shift from the left, you always shift in zeros. And so negative 4 shifted 5 is 0. Okay, we'll look at 38 shifted to the right. It's a positive number, so we're going to shift 3 positions and lose those 3 digits in red. And we're going to shift in zeros from the right, or left. Yeah. And we'll end up with the answer of 4. T-min. When you have 2's complement number, the minimum number is always 1 followed by all zeros. Or if you want to know the math, I think in your book they call it W, I call it K because my name's Kevin. You just pop in 2 to the 7 minus 1, which is 2 to the 6, which is 64, and negate it, and that is the minimum T minimum value. T max is you leave the sign position 0 and you fill in all the rest with 1s. Or you can take 7 minus 1, 2 to the 6, 64, minus 1 is 63. That is the T maximum number. Feel free to interrupt, but I'm going to run faster through these first kind of data format questions. Okay, these are a little bit more complicated. We have T-min plus 1. So T-min is a 1 minus followed by 0, so negative 64. We're going to add 1 to that. We do simple bitwise digit arithmetic, and we get that number, which you should know, or you should be able to use complement in N plus 1 to figure out is negative 63, which we've already done. Okay, negative T max is negative 63. Negative T max, okay. So you take 63, which is T max. You complement it, which is going to be negative 64, which we've seen. You add 1 to it, and that's negative 63, which we've also seen. So I'm skipping a couple steps here. Okay, now we'll look at T max minus T min. T max we know is 63. T min is negative 64, but where it's minus T min. So we need to negate that. So we'll complement, get 63, we'll add 1. And negative T min is now negative 64. It's the same. We add T max to that. And we do all our bitwise additions. And we get straight ones, which is negative 1. So this is a little counterintuitive. But this is just basically the wraparound occurring. The next problem is T min minus T max. So T min we know is negative 64. T max is 63, but we've got to negate it. So we complement, we add 1, and we get negative 63 plus negative 64, and the answer is 1. Because we overflow off the top, right? Okay, we've done integer representation. We're now going to do